Hello, everybody. I'm Dr. Bob Morris, Professor of Biology at Wheaton College in Massachusetts. Welcome to another episode of Science with Dr. Bob. You know, I'm curious about how life works. That's why I'm a biologist. I study small life. I study cells, in fact. And to study cells and to learn how they work, you have to study the smaller parts that are within them. Those are molecules. Molecules are collections of atoms that have their own behavior and work together to create larger objects. We can see how molecules interact, but they're too small to see themselves. So, what molecule are we going to study today? We're in fact going to study water. In a previous episode, we saw that an underappreciated dangerous effect of climate change is ocean acidification. And we used a purple dye to study acidity. Well, what is acidity? And what does it measure? It all has to do with water. Water is a magical molecule, and I have one right here. There it is. Water is H2O. There's two hydrogens and an oxygen together. That makes a water molecule. And water has amazing properties, one of which is that it falls apart. Water is a fickle molecule. Hydrogen will sometimes leave and go off by itself. And this is a very common property of water. It'll come back together and it'll pop off and do other things. In fact, the amount of this hydrogen ion in water is so important it has its own names. So water is H2O, and when hydrogen leaves, it carries just itself. It's just a proton. So we call this a hydrogen ion, we call it a proton. And we measure it with its own property. We call the concentration of hydrogen ions in solution, we call it acidity. And it's so important to know what acidity is present, that it has its own measurement. We call that measurement pH. And as pH numbers drop, the amount of hydrogen ion concentration rises. So pH measures acidity. And how do we study that? Well, let me dry my hands here. To study water and to study pH, we need an indicator for those hydrogens in solution. We call that a pH indicator, and we used one in our previous episode. We used this purple dye. It's actually a molecule we call anthocyanin. It comes from red cabbage. It is the purple molecule that makes red cabbage purple and makes eggplant purple and makes blueberries blue. And we can use that molecule to study acidity. Plants use it to attract pollinators. It's a metabolite. They use it in their own metabolism. We're going to use it to look at pH, to look at acidity in water. So let's create that pH indicator, and we do that with an experiment. So let's do that experiment. What I've done is I've taken my red cabbage and I've chopped it up into small little pieces here, and I've put them in this pot. And then with boiling water, you just pour the boiling water onto the cabbage pieces, and that will extract the anthocyanin. Now I'm going to just let that cool overnight. That's what I did yesterday. The pot's a little bigger, but here is what those cabbage pieces look like when we've let them cool overnight. We have the cabbage in there. It's extracted the anthocyanin. So all I need is a colander and a container to catch the purple pH indicator, the anthocyanin. And there we have it. That's how you can make your own red cabbage pH indicator. So I have some of that collected right here. And we can use that to look at the acidity of a variety of solutions you might have around your house. So let's do another experiment. We can't see the molecules themselves, but we can see the way they interact with light or other things. In this case, we can see that anthocyanin molecule if we dilute it into another solution. So this is anthocyanin in water. Let's just dilute it into some more water. Now, anthocyanin is a pH indicator, and when it is in water, remember there's hydrogen ions in that water, and it binds to those hydrogen ions. The anthocyanin in water that's a little bit acidic, my water is a pH of 6, a little bit acidic, it actually absorbs all the colors except purple. So the purple passes through and back to you. So you can see that the anthocyanin, that the pH indicator in water is purple. Well, what happens if there's more hydrogen ions? If we try this in just soda, this is just Sprite, well, check it out. The anthocyanin has bound up the high concentration of protons, the high concentration of hydrogen ions, and now it absorbs the purple, but it passes that magenta. What happens if we go into a very high concentration of hydrogen ions? High acidity, low pH, that's in this vinegar. And now the anthocyanin is actually binding up those protons and changing its color from what was purple now to red. So our water is a pH 6, our Sprite's a pH 4, more acidic, and our vinegar is a pH 2. That's about the same pH, the same acidity as is in your stomach. So let's see what happens if we add the anthocyanin to a solution that has less protons in it, less acidity. Baking soda is a pH 8. Now that's a teaspoon of baking soda in water, and that's now turned blue to blue-green. And what happens if we go all the way to ammonia, pH 10? Oh yeah, straight on, full-on green there. Well, there's an example of how you can use water to extract a molecule that lets you study water. And this pH indicator is in fact not changed by this reaction. It's a reversible change. It has bound to more protons here and turned red. It's shed protons here and turned blue, blue-green. So what if we take some of that vinegar and pour it into this baking soda solution? Well, you've seen water and baking soda before, I'm sorry, vinegar and baking soda before make carbon dioxide. There's the carbon dioxide. And there's the pH change. We can go right back to the same color as our water by adding more protons to change the color of that purple pH indicator. So, today we learned that to study molecules, you look for what they do. One of the things that they can do is change the way they act with light. One of those useful molecules can be purified from red cabbage. Red cabbage pH indicator called anthocyanin, and we can use that to study the acidity, the pH, of different solutions. I encourage you to try this yourself and convince yourself that this is the way that pH indicator works. Try different solutions and come up with your own rainbow. By extracting these molecules, we can actually study the properties of water. One of those very important properties is acidity. So for more information, come to sciencewithdrbob.com, and until next time, keep on experimenting.